6.2 is division of polynomials. We'll talk about dividing by monomials, using long division, using synthetic division. I'm going to start by doing division of a monomial. Monomial means there's only one term down here. There's no addition or subtraction, just one term down there. I'm going to do basically each piece here divided by negative 4x squared. Every single piece is divided by negative 4x squared. And if you want to, you can think about it like it's 5 separate fraction problems. All that happened was this I wrote as one fraction, and this I wrote as one fraction, and you kind of do it in those 5 little pieces. Now, I don't actually recommend writing it out that way. Just know that's essentially what's going to happen, is that every single thing is going to get divided by negative 4x squared. So I'm going to do 12x to the 7th divided by negative 4x squared. Well, 12 divided by negative 4 is negative 3. X to the 7th divided by x squared is x to the 5th. So that becomes negative 3x to the 5th. I'm basically going to follow that process for every step along the way. Negative 8 divided by negative 4 is positive 2. X to the 6th divided by x squared is x to the 4th. 6 divided by negative 4, they don't divide cleanly, but 6 divided by negative 4 I can reduce to negative 3 over 2, and x to the 4th divided by x squared is x squared. 5 and negative 4 can't reduce at all. This will become 5 over 4x. And then negative 4x squared and negative 4x squared. Well, negative 4x squared divided by negative 4x squared is actually just a positive 1. You have to keep that plus 1 there as a placeholder. They don't cancel each other out entirely. That was kind of gross. They don't cancel each other out entirely because something divided by itself is 1, and you get that. Notice that every degree, every power, drops by 2. You're dividing by a power of 2. Next is long division. Before we do long division, I'm actually going to talk about regular long division instead of our polynomial long division. First, I'm going to clean this up a little bit. I'm going to get rid of this 0.9. If I'm doing 14 into 1870, in fact, I'll make this one number bigger, 12,870. 14 to 12,870. Remember, the number on the bottom goes out in front. That can often be confusing where to start. This number goes on the front. Well, first I see, can 14 go into 1? It can't. Can 14 go into 12? It can't. So can 14 go into 128? Well, 10 times 14 is 140. So I think 9 times 14 is what I want. This was the last digit I was going into. My 9 is going to go above this 8. The columns are very important when you do long division. 9 times 14, well, 9 times 4 is 36, so 6 goes here and 3 goes here. 9 times 1 is 9, plus 3 is 12. I get 126, I had 2 left over, so that was a close one, but I want this number to always be less than this number. If it's not, I've done something wrong, I gotta go back a little bit. Now I can drop down this 7. 14 goes into 27 once. 1 times 14 is 14. 27 minus 14 is 13. Now I'm gonna drop down, stupid valve. Sorry for the interruption, I'm going to get back to it. We had just done 27 minus 14 to get 13. 13 is less than 14, so that's good. Now I can drop down this 0. 14 goes into 139 times. I already know that 9 times 14 is 126, because I just did that. I subtract again and I get a 4. Now at this point, I could add a decimal and I could drop down a 0 if I wanted to go and get a decimal expansion. But what I actually am going to do here, let's talk about remainders. You haven't seen remainders in a long time, probably. But for this remainder, I can actually do 4 over 14. Remainder 4/14. So my answer is really 919 with a remainder of 2/7, because 4/14 can reduce to 2/7. That decimal, whatever I would have gotten, had I put down this 0 and dropped down a 0 and kept going, had I done that decimal out forever and ever and ever, it would have been the same as whatever 2/7 is. So that same idea about worrying about columns, doing your multiplying, adding, subtracting, all that action. I'm going to do it again with these things over here. As you can see with this division, all of these numbers here are even, which means they could all be divided by 2. If I wanted to pull out a GCF of 2 from this, and pull out a GCF of 2 from the bottom, and then cancel those 2's, I could. And that would make the problem, you know, twice as simple. I'm actually not going to, because I want to show what happens with these. But I want to show how to do this. I need to be very, very careful about places. This has an x to the second term and an x to the 0 term. It's like that's 4x to the 0. But it's missing an x to the first term. So when I write this out, I'm going to have 2x squared plus 0x to the first plus 4. And that's going to divide into 2x to the fourth plus 6x to the third plus 2x squared plus 12x minus 8. In this case, that missing 0x term that I snuck in there isn't going to be critically important, but it is helpful. In other cases, it can be critically important, so always do it. Just like before, over here, I saw how many times 14 went into 128. Here, I only check the first term.
Maddie D. McCarroll, please come to the front office. Maddie D. McCarroll.
How many times does 2x squared go into 2x to the fourth? I'm only going to be checking the first term. I'm basically asking 2x squared times what equals 2x to the fourth? Well, obviously 2x squared times x squared equals 2x to the fourth. 2x squared times x squared is 2x to the fourth. So I'm going to put an x squared over here in this column, where I'm matching up the x squared columns. I should erase this better. After the whole thing. 2x squared was there. I put that x squared over in that 2x squared column. And now, just like before, I'm going to do this times all of this. Just like over here, I did 9 times all of this. Well, x squared times 2x squared is 2x to the fourth. Just like we drew it up. X squared times 2x squared is 2x to the fourth. Excuse me, I'm going to pause it again. X squared times 2x squared was 2x to the fourth. Then I do x squared times 0x, which is 0x to the third, which I know is kind of weird, but deal with that. Then x squared times 4 is 4x squared. And here's the part you're going to mess up. Just like how over here, we always did subtraction. Over here, we do subtraction, but we're subtracting the whole entire thing. So what I actually do is I take all these signs in the middle, and I switch them. I switch them from pluses to minuses, and I put a minus here and a minus here. And I'm going to subtract all of these things from each other. I'm going to read these parentheses now. So when I do that subtraction, 2x to the fourth minus 2x to the fourth is 0. That's the whole point. 6x to the third minus 0x to the third is 6x to the third. 2x squared minus 4x squared is negative 2x squared, and I drop down the 12x. Just like over here, I drop down the 7. Okay, I'm only checking the first thing. 2x squared goes into 6x to the third 3x times. 2x squared goes into 6x to the third 3x times. So 3x times 2x squared is 6x to the third. 3x times 0x is 0x squared. 3x times 4 is 12x. I subtract again. When I subtract these again, all these signs switch. So this plus is really a minus, this plus is really a minus. When we do this subtraction, we actually get 0, 0, and 0. So everything's gone. And that's okay. It's kind of nice when that happens, actually. Drop down to negative 8, and we have a negative 8 here. Now at this point, I know that 2x squared can't go in to negative 8. So I'm basically done with my dividing, and now I make a remainder. This number that is left over becomes my remainder. So I get minus 8 over 2x squared plus 4. So if it's 8 over 2x squared plus 4, this can actually reduce. I get x squared plus 3x minus, I can divide everything here by 2, so it's minus 4 over x squared plus 2. Just like how over here, this became a remainder from these two things. The same thing happened over here, remainder to remainder. That is long division. That is about as bad as it gets, actually. I made a really dirty one so that when you watch the video, you can see all the pitfalls that can happen. This next one is called synthetic division. You're going to like it much better. Synthetic division is really nice, but it only works if you have a linear binomial, meaning this doesn't have any power besides 1, and there's only 2 terms. What I'm going to do is write down all the coefficients of these powers. So I have 2x to the 4th, 5x to the 3rd. I have no x squared, so I have to put that 0 there. I have 5x and negative 14. Having this 0 term is the thing people are going to forget. You have to have that placeholder for the no x squared term. So 2x to the 4th, 5x to the 3rd, no x squared, 5x, negative 14. All those powers of x are covered. Now, I'm put this little right angle box corner thing up here. I draw that. And I plug into this box whatever makes this equal 0, which in this case is negative 3. I'm going to put a negative 3 into this box. And then when I do, draw a little line down here and I set up this form. First thing that happens in the synthetic division is this 2 drops down and I just write it here. And I do 2 times negative 3. 2 times negative 3 is negative 6, and that goes here. I add those up. 5 plus negative 6 is negative 1. Negative 3 times negative 1 is 3. I add those up. 0 plus 3 is 3. I multiply. Negative 3 times 3 is negative 9. I add. 5 plus negative 9 is negative 4. I multiply. Negative 3 times negative 4 is positive 12. I add. Negative 4 plus 12 is 2. Negative 2. Since I am done, this last thing always goes in a box. Put that last thing in a box. And now here's where it kind of gets tricky. Whatever this biggest power was, whatever the degree was, drops down by 1. So that was to the 4th, so I get 2x to the 3rd minus 1x squared plus 3x minus 4 minus 2 over x plus 3. The number in here becomes my remainder. It's divided by whatever this was. And that is synthetic division. Thank you, everyone.